this is topic 2.3, and today we're going to understand the geometric definition of rotations as composition of two transformations. So similar to what we did with reflections the other day. All right, on your notes, you will need a couple sheets of patty paper. So what we're going to do is we're going to trace this onto two different sheets of patty paper. So I want you to just pause the video for a second and go ahead and trace the two lines, M1 and M2, and the triangle onto two different sheets of patty paper. All right, point P is going to be the point where the two lines intersect, so we're going to call that point P. And then we are going to reflect the triangle ABC over line M1. So remember to do that, we're going to paper fold. So we're going to fold, here's line M1, and I'm going to fold this along the line. So we're just going to fold it and crease it. And then I'm going to trace, so I just folded it along line M1, and I'm going to trace that. Now, make sure that you get your fold exactly on there, and then I'm going to mark my points. This is going to be A prime, B prime, C prime, and if you need to, use your straight edge to draw straight lines if you can't draw those. Okay, make sure they're straight. Okay, and you can see it through your paper here, or if you want, you can trace it again on the top of that. Okay, so now that we've reflected it, now we're going to reflect it again over line M2. So we're not going to reflect the pre-image. We're going to take the one we reflected with the primes and we're going to reflect it again. Okay. So I'm going to fold it this way along line M2. And I want it to appear here. So when I'm going to trace it and mark my points. Again, if you need your straight edge, use your straight edge. So this is going to be a double prime. This is going to be B double prime and C double prime. Okay, so when I get finished, this is what my end result is. Now, if you would rather see it all on one side, you can just trace these. A prime, B prime, C prime, and then trace these. C double prime, B double prime, A double prime. Okay, and so this first one, triangle ABC, reflected over line M1, and then we took that triangle and we reflected it over line M2. All right. So it says, is the final image a translation of the pre-image? So yesterday we reflected over parallel lines and all we had to do is just translate that. Well, we can see that this is not a translation because of the orientation that we've talked about. So if I move around this triangle here, I have triangle A, B, C, and I'm going counterclockwise. Well, here, triangle A, B, C, and I'm still going counterclockwise, but my points are not in the same position. Okay, so it's not, appears that there's been some sort of turn that has occurred, and that's what we want to answer in question 1. So it says, is the final image a translation? And it's not. And it looks like we've kind of turned our triangle a little bit. So for question number 1, it says, is it a translation? No. Triangle ABC looks, it's not a translation. It looks more like it has turned. And if you'll remember, if it's turned, that's what we call a rotation. So I just put no, triangle ABC is rotated to triangle A double prime, B double prime, C double prime, and that should have a triangle symbol there. All right, so now this is where we need our other piece of patty paper, and we will follow along with the animation. So take your clean sheet of patty paper, the one that you have just the one triangle on, and you're going to lay it on top of your patty paper that you reflected. And then you're going to put your pencil on point P, and you're going to turn that top sheet of patty paper, hold down on point P, and just turn that top sheet and see if it truly does rotate. And you will see that A double prime, or A prime map to A double prime right here, B maps to B double prime right here, and C maps to C double prime. So you can see that in mine right here. Okay. All right, so now we're going to do some measurements, because now that we know that it rotated, we want to know, well, how much did it rotate? And this is where we're going to need our protractor. All right, so we know in our notes that a rotation is the rotation of a point about a fixed point is the composition of the reflection, and it's of intersecting lines instead of parallel lines this time. Okay, and the point that you're rotating around is what we call the center of rotation. Now it says to compare the orientation of triangle ABC and triangle A double prime, B double prime, and C double prime. Now we kind of did this, I already talked about the orientation, but both of them go counterclockwise, so they do have the same orientation. So rotations are going to preserve that orientation, where reflections do not. Okay, and it says, do you think this is true for all rotations? And we are going to say yes. They do preserve orientation. And that just means that the orientation stays the same when you have performed that transformation. Okay, so now let's do some measurements. So in your notes, you'll see that they want you to connect these segments, so PA, PA prime, and PA double prime, and then we want to measure those. And you can use inches or centimeters. I would suggest using the centimeters just because you can get a more precise answer. All right, so find your piece of patty paper. And let's see if I can make this bigger. There we go. All right, we are going to connect P to A. If I can get a pen that works. Okay, well, we'll try pencil. May not show up as well, but at least it'll show up. There we go. And then we're going to connect P to A prime, and then P to A double prime. And then in our notes, we're going to record those lengths. Okay, so again, I'm going to use centimeters. So that appears to be 2.4 centimeters for the first one. And then this is also 2.4 centimeters. And then the last one is also 2.4 centimeters. So we can see that when we rotate, that point stays the same distance away from that center of rotation. So think about if you pulled this string taut and you had it, and then you rotate around, it's staying tight, and then it's the same distance away. And you rotate it again, and it's the same distance away. So we say that it preserves distance. Okay, so it's the same distance from that center of rotation. Okay, now we're going to do some measurements of angles. So you're going to need your protractor. This is the one I'm going to use. Yours is the clear one. And we're going to measure angle APA double prime. So that means since P is the point in the center right here, that means that has to be the vertex. So this right here is going to be our vertex. And we're measuring this angle right here. I'm tracing it right here. Okay, so it appears to be obtuse. And I'm going to have to extend that to make it longer. Most likely, since you have a bigger protractor, you're going to have to also. So I'm going to put the protractor right on that point P. Yours may or may not have this circle hole with these lines right here. If it does, that's where your vertex is going to go, and then you're going to line that up on top of one of the sides. And then you'll see where that goes through. So that looks like 152. So we'll just say 152 degrees. And then it says to measure the acute angle of your intersecting line. So we used M1 and M2, and I'm going to use this one just because I've got so many things drawn on this. And the acute angle is obviously the one that's less than 90 degrees. So that would be this angle right here. So that's the one I'm going to measure. And I'm going to have to extend one of the sides out so that I can measure it. So I'm going to measure or extend this one out just a little bit. And then I can line that up on that intersection. And that looks like about 76 degrees.